Hello students, this is exercise week 4 in emerging trends in software engineering. So last week we did word clouds, that was part 5 of the exercises, and in this week we will move into part 6 and part 7. So in part 6 we will cover timelines, so basically we will show and report timelines where the number of sources can be seen over time. And we will also assess popularity, which means in scientific papers, the number of citations. In terms of Stack Overflow, it means the number of upvotes. And in Twitter, we consider popularity from the measure of retweets. Also, part 7 will be covered, which is qualitative analysis of top 5 popular sources. So there you need to list and explain the top 5 sources for each of the 3 datasets. And you need to explain what topics are discussed in the top 5 sources, what are the differences, and what are their commonalities. Okay, let's start with the timelines. Okay. I'm here in RStudio. As I start this session, I run the initialize.r always. And now I move the file called timeline.r. And I have my example data file, which is all the articles from a journal, Transactions on Software Engineering. So I load this file to memory. Now I have it. Let me move my head. And as you can see, the My Articles contains 3,591 observations. Means 3,591 papers. Okay, and now I'm interested in the years when the papers have been published. So I use a package called Lubridate. If you don't have it, you should install it. This happens on line 17, but I already have it, so I can just take the years. And I can see that years comes out as numeric. So let's look what we have in years, and I can see I have 3,591 entries, and for each I have the year when it was published. And a very simple way to look at this data is simply to plot it. So first I make a table. I confirm that I have a table which is yearly, and then I plot it on the screen. You can see it right now. Again, I have to move my face, and you can see I have the number of papers. But as you can see, the years are not yet shown, so I execute line 27, which adds in the years. And now you can see the years as well. And if I slide this a bit, it will become a bit more informative. And we can see that the highest numbers of papers in these journals have been published in 1998 and 1998. And since then, there has been some decline. We can see the yearly variation in this. For your topics, this analysis would make much more sense than it does in this case. In here, we are analyzing a particular journal. And it is always an editorial decision how many articles will be published on the journal. However, if you take all the papers of a particular topic, let's say you are investigating test automation, then you can see how the popularity of the topic test automation, for example, has increased or decreased over the years by plotting such a timeline. Now, what is shown at the moment shows the yearly timeline. However, for datasets coming from Stack Overflow and Twitter, we might be actually interested in the daily timelines, not the yearly timelines. So this is also done in lines 30 and 31. So we take the date variable and form it as a table, and then we plot it. But now we see this. We can see that there is a problem. We can see that some dates have much more papers published than others. And we can see this in more detail if we investigate the data. So we have the date variable here, and I will execute it so it becomes to the console. Now I will investigate this. So the data here shows a date, for example 2018 April 20, and one article was published on that date. And in March 2018, April 2018, on the 14th, 2 papers were published, and so on. We can see, 1, 1, 1 here on the bottom row. So we can see that for each individual date, only few articles have been published. But if we go to the earlier years, we can see that basically the date information is not correct. We can see that all the papers for a particular year are marked to the 1st of January of that year. So in 1975, 1st of January, 44 papers, and then the next date that appears in the data is from the next, from the 1st of January, 76, 77, 78, and so on. And this explains the figure. So for the early years, the dates are not correct. They are simply set to a particular month once a year. And again, this plot doesn't make very much sense. However, for Twitter and Stack Overflow data where the date information is accurate, and you might also want to investigate only a particular year, for example, investigate the previous 12 months, then doing the timeline analysis with only using the date and not the year would be a much more sensible choice.